Bismillahirrahmanirrahim. This video will explain on antiderivatives. So for this, you're going to introduce to the concept of the integration as the reverse of differentiation. Okay, as we discussed in the class previously. So integrations as the reverse process of differentiation, and it is also known as antiderivatives. So let's check on how we can show that this is the reverse process of each other. Okay, so the first example that you have here is fx equals to 4x to the power of 3 plus c. So when we say that it is the antiderivative of that, we try to find the derivative for this function. So let's say we find the value of f prime x for these functions. So recall back the power rules for the differentiation. You're going to bring the index to the front, right? So it will be 12x to the power of 2. You're going to minus the index by 1. And if we c is any constant, so by differentiation, the values can be ignored, or you will get 0 for that. So this is the values of differentiation. Okay, after you differentiate, this is your answer, right? Okay. From that, we are going to integrate the result from differentiation, meaning that we are going to integrate these terms with respect to dx. Okay, so I will rewrite this: integrations of 12x to the power of 2. Okay, so this is the integral sign, and then we need to have the dx term, which means that the variable involved in our case, okay, with respect to x. So integrations of 12x squared dx, this will give you the values of 12x to the power of 3. Noted, the rules is adding 1 and divide with the new index. So 12x to the power of 3 over 3 and then plus c. Simplify for this will give you 4x to the power of 3 plus c. Okay. If you noted what we get now, this one, 4x to the power of 3, it is equals to the original equation, the original functions. So now these two are equals. So that's why this is called as the reverse process of differentiation. Okay, reverse of that. From the original function, we differentiate and then integrate back this function, then you will get the original functions. Okay. So this idea can be used in the next example. We'll see how can we apply this idea in order to find the original equation. Okay, maybe we need to find the original equation for that functions, or depends on the function. Maybe we want to find the integration part and so on. So let's check on the first example that we have. Okay, so these figures, the things that you have in your book, right? So here, okay, from 4x to the power of 3, 4x to the power of 3 plus c, if we differentiate this, okay, differentiation of that will give you 12x squared. And then if you integrate this one, okay, to the left, you integrate that. Okay, you integrate this one, then you are going to get back this original equation. Okay, so that's the figures that you have in your book. Okay, so now let's continue with example 2. So example 2 given, if f prime x equals to this one, 3x squared plus exponent 2x and plus 2, and f0 is equals to -4, find fx. Okay, so this question require you to find the original equation or original functions, and you are given the information on the derivative, okay, derivative of this, and also these coordinates. Okay, maybe these coordinates we are going to use it later on when we want to replace or find the other values. Okay, so from here, you know, when your x is equals to 0, fx is -4, right? Okay, so how can we use this information? So we know, given that f prime x is equals to 3x squared e to x plus 2. Okay, So just now, we know that in order to get fx, okay, we can get this fx if we integrate the derivative values. Okay, so integrations of f prime x dx will give you the value of fx. Okay, so that's the idea. So let's replace with what we have. Okay, given f prime x is 3x squared plus e2x plus 2. Okay, this is given. So we are going to integrate this. So 3x to the power of 2, to the power of 3 over 3. And then e2x divide with 2. Okay, differentiation of the index. And then integration of 2 will give you 2x. Okay, so one more thing, we have plus c here. Okay, so this is the value of fx, our fx, but we have c that need to be find here. Okay, so how to find this c? Okay, we have this information, f0 is equals to -4. Okay, so let's use the information to find the final values for this fx. First, we need to find the c. Okay, so given that f0 is equals to -4. Okay, this is the given information. So we are going to replace everything. Okay, when your x is 0, replace 0 here and 0 here and here, and then equating to -4. Okay, so we are going to get for this 0 over 3. So obviously you will get 0. Okay, then exponent 2 to the power of 0. Then you will get exponent to the power of 0. Anything to the power of 0 is 1. So it is 0 plus with 1 over 2. Okay, and then 2 with 0, you will get 0. Then we are looking for this c. So this should be equals to -4. Okay, so with that, we can solve for the c term. So your c should be equals to -4 minus 1 over 2. Okay, so it is -4, 1 over 2. So once we get this c value, you see, then we can replace it into the fx term. Okay, so with that, we are now getting the final answer. So the final answer should be fx. Okay, we are looking for fx just now. Should be equals to x to the power of 3. Okay, this one can be simplified. Plus with e 2x over 2. Plus with 2x minus 4, 1 over 2. Okay, so this is the final answer. Now let's continue with one more example, example 3. So previously, example 2, we find the value of fx where you are given the value of f prime x. Okay, so now let's check what is the difference with this equation. Okay. Find gt. Okay, again, we want to find the function if the integrations of gt, okay, so noted here, you are given the integral sign. The integration of that equals to, okay, this one, 1 over root of 4 minus t squared plus c, okay, where c is the constant. So previously, when you are given the derivative, you will integrate that to get the original equation. So now you are given the value of integral. Okay, so this one, the integrations of gt dt is equals to this. So this is the result from integration. So in order to get the value of gt, we are going to use the idea of differentiation, right? So let's see what we can do for this example. Okay, so you are given this 1 over 4 minus t squared. Okay, so let's say we let this one to be one of our functions so that we can find that later on. Okay, so it is 1 over root of 4 minus t squared plus c. Okay, and this one can be simplified in terms of negative index. It should be 4 minus t squared to the power of -1 over 2 plus c. Okay, so we want to find gt. The question asks us to find the value of gt. So this gt can be found by differentiate the values of integrations. So what is the value? This one. Okay, differentiation. So differentiation of this will give you the gt function. Okay, so gt is equals to dy over dt. Okay, in case that we assign this one as our y term just now. Okay, so let's find the derivative for this. So recall back, this is just the power rules idea. No, it is combined with the composite function. Okay, so bring the index to the front, 1 over 2. Copy everything here, and then you need to minus the index by 1. So negative 1 over 2, negative 1, it is negative 3 over 2. Okay, copy everything. And then you need to multiply with differentiation of the inside values. So differentiation of this part, okay, differentiation of this will give you negative 2t. Okay, differentiate that, you will get negative 2t. So we can simplify for this. So this negative 2, okay, along with the sign, we can settle out. And what's left, there is only t. Okay, and this is negative index. We can change it to positive index. So t over 4 minus t square to the power of 3 over 2. Okay, so this should be the final answer. Okay, because the question asks you to find the value of gt.